Everyone, buenos dias. My name is Andrei Costin, and I'm a senior lecturer in University of Jyväskylä. A couple words about myself before we start. But I'm very excited to be here, and thanks for Politecnica Valencia and Felipe and SmartSoc for organizing this nice school. I hope you're enjoying so far. I think some of the teams have been also in touch with me about some of their projects, so we will see some familiar faces and we can discuss. Okay. So, well, I started as a software developer in 2007 in Cyprus, also quite Mediterranean place, and then I started doing a little bit of research, and I got interested in research. So never say never, right? If you think you're gonna be a software developer for all your life, maybe you change your idea, and vice versa. If you think you're gonna be researching all your life, maybe you will end up in corporation being a big director or manager. So the life can change and your preference can change. So again, I started as a software developer, and then I did my PhD in Euricom, south of France, also quite Mediterranean, but a little bit more north. And once I completed my PhD, quite soon after that I moved from Mediterranean to this. So we have quite a lot of snow in Jyväskylä there. Welcome anytime. There's also a big university there, so if you want to do research, it's also possible, and you actually have some colleagues from University of Jyväskylä around here. Some of you maybe have them as teammates, Lassi and Anthony, I think. So they are from University of Jyväskylä. So now this is where I am. I'm a senior lecturer, assistant professor, docent, a lot of titles, but anyway, what I'm doing is teaching and researching cybersecurity. And also what I'm trying to present today, because, well, in smart society, well, we see that cybersecurity is what we actually need. I'm sorry, I'll pause because too much noise on this side. Yes, so my main research areas are in system security in a broad and applied sense. But anyway, that's software and IoT devices and firmware security. If you have any questions about that, I'm happy to answer during the lecture or after the lecture. And of course, doing some machine learning based applications to security and privacy. And again, machine learning is a hot topic because I think a lot of projects are trying to use machine learning, or I'm quite sure that all the projects we have here in the summer school have some sprinkle of machine learning to it. I'm pretty sure every team has a slide with machine learning, or I hope so, and there's substance to it. So, well, there's a lot of things you can read, but but it's not about me. I just want to give context what I'm doing and what I'll be presenting today. And well, again, the SmartSoc projects you are doing are definitely intended to build a smarter society from different perspectives and build the digital skills. And because everything is digital, cybersecurity is really important, right? To make it very simple to understand, digital, basically, you have everything digital. All your documents, all your boarding passes, or your money, everything is digital, right? So this is all your asset. Now, if you go to a bank and you have money, physical money and gold, and you go to a bank and you ask, do you have security guard? And they say, no, we are just open door, everybody comes in, everybody comes out. Would you put that money in that bank? Or 1 kilo of gold? Would you live in that bank with no security guard? No. Okay? So the idea is that why do we do this with digital assets? Why do we have digital assets which are worth all our life, and we say, well, security is nice, but it's not necessary. We don't do this with normal banks, right? So this is something to think, and what we do in my research group, we do system security in the sense that we try to be playing the hackers in the sense the good way. Okay, so we show how the system can be hacked or broken, and that's the whole idea. We develop systematic approaches that can be reproduced, so it can be generalized, so you understand how we do it and why we do it and how the attackers are doing it. Okay? And this is a little bit about who I am. Now I try to switch to the next. There's a slight change in the presently. Well, I'm not quite sure how to change on this system. Ah, okay. No. Now it's this one. Yes. Okay. Because it was. So, well, for multiple reasons, there's a little bit change of the title and a little bit change of the topic for today, but it doesn't change the core idea about cybersecurity of today's topic that I want to present. And I will also try to make it a little bit more interactive, so everybody warms up and gets ready for the mood. Because I think every project we have in this summer school, they are more or less technology and involve software, right? So there is some kind of a mock-up, some kind of some demo, proof of concept, and it involves software. So in order to be cyber secure any system, like you make a super application in this summer school, and then you want to go and pitch it or sell it for billions of dollars and say, hey, I have a best application. And the next question, is it secure? And you make a pause and you're like, not quite sure. So let's discover this. And because it's software, the topic is why developing secure software is hard in general. So you understand what kind of problems you'll be facing if you take this project and go along with it. So this is the main agenda that I try to propose. Okay, we will start some quiz discussion to understand what are your levels of security, but then we will look at some definition and tackling the question that we want to answer, like why developing secure software is hard and why bother after all. But as I mentioned, we need to bother because these are all digital assets. And then discuss a little bit solutions, and then I try to set aside maybe a couple minutes that we do some very small group work and then discuss based on that and conclude. But then the main question, why do we need cybersecurity besides the simple example with the bank example, right? Where you would not leave a kilo of gold in a bank that has no security guard. It would be insane, right? So this is just an example that you can say, and somebody will tell you, well, but this is made up example. But the world is changing, and for example, in US, but it's going to be everywhere soon, that basically the Security Exchange Commission, the organization that monitors the dealings of companies in the US, all the mergers, acquisitions, formation of companies, everything which deals with the companies, they now requiring or are in the process to make legislation that has these rules, propose new rules, basically that public companies have to report cybersecurity breaches. They must. If they don't, they will have a big fine and then they'll go out of business. So imagine you're building a business many years and then you get hacked and you don't report it and your business is gone. Billions of dollars gone in 1 second, okay? Not just because of the attack, but because also you don't follow the rules. But this is just, again, explaining the context. And besides that, it's not that, okay, you have to report it, but then there are these kind of positions like cybersecurity officer or cyber chief information security officer or CISO that will be mandatory to be in the board and will have to be part of the board and report to the board about cybersecurity, because it makes all the sense that if all the digital assets, or if all these assets are becoming digital, especially we are moving with crypto and everything, we need to have somebody protecting the digital asset. I mean, it's obvious, but somehow we are lacking this in the current digital mindset. So this is one of the key motivations that soon all the companies, unless you are a tiny startup with 2 people, will have some kind of cybersecurity person and mandatory reporting to the board and to the other organizations. Now let's try to do this warm-up and quiz discussion a little bit, so we make it a little bit more interactive. How many projects are here in SmartSoc? 7? Okay, I'm quite sure you are somehow clustered, but I think some of you are also scattered, right? You're not sitting project-based. So how many of you did or will write, well, how many of you did write software for the SmartSoc presentation and stuff? No, how many will write some software? No, okay, no software. Generally the projects are software oriented and software based. So all the projects are software oriented or software based, but nobody yet wrote a single line of code or. Okay, no, I completely understand this is not. I know it's short time and the purpose is not to make a software, but basically to make the presentation and the concept of your technology. Okay, now in your project, how many of you, even before writing the software, how many of the projects or how many of you thought about cybersecurity? Do you have anything about cybersecurity in your project, in your presentation, in your planning, in your unique selling proposition, in your, I don't know, risks and weaknesses? No, you have, yeah. In the risks, or can you detail?
We basically have to deal with a lot of user data that we collect, and that needs to be anonymized and stored securely. We also need to take care of like user accounts and logins and passwords and encrypt and hash all of that. So that's basically our primary concern, to create secure databases.
Okay. How many, except this project, how many deal or plan to deal with user data? Do you have users? So every other project deals with user data, but nobody else did cybersecurity or thought or put in the risks or assessment. Again, that's more discussion. You don't have to feel, oh, it's really bad. It's more to generate thought, right? To understand why you didn't put it, maybe lack of time, lack of understanding, and the idea is to keep the thing growing. Okay. Well, now it's how many of you implemented security. I assume that since there is no particular code written and mainly more like a business plan and business model canvas and kind of analysis and no code written, I assume that there is no particular implementation of cybersecurity, right? Except, well, even the project that mentioned this, right? Okay. And then, of course, how many tested cybersecurity? And of course, in order to test cybersecurity, you need to have something implemented. If you don't have it, of course, it's more like just a thought process. It's good to make a plan, to have a plan, but so you see, like very simple question. Now it's a simple question. Okay, cybersecurity, but it needs some process. Did you think about it? Did you put it in your project roadmap, mindset, business plan, risks assessment, weaknesses? You don't have to write tons of documents at this stage or even at pitch stage, but you need to already have this mindset. And why this mindset is important, again, as I mentioned, it will be required or mandatory, but it also will help to be ahead of the competition. If there are two products and one is, let's say, I don't know, these delivery companies have billions of users or millions, if one has security and one doesn't, most likely the other will say, well, I better choose the one who protects my data, not the one which doesn't protect my data, no? So it's also a competitive advantage to have. Well, now let's go a little bit back to the more technical side of it, or the software and secure software, and why it's difficult in general to have secure software. Again, I suppose many of you still have some kind of, besides the SmartSoc project, many of you have software-related degrees, right, or experiences. Yeah, how many have directly software-related degrees? Okay, and the other who have not raised their hand, they are more like business degrees in technology or
business.
Yeah. Okay. Yes. So basically, of course, this is relevant also for the ones who are not necessarily doing software. Yeah. It's also important to understand for non-technical people, or for CEO or CFO or whoever it is. It's also important to understand why developing secure software is hard, or why does it cost 10 times more than simple software. Like, you have to be able to understand as a CEO or CFO why, if you want secure software, your budget increases 10 times. And it's not because the developer says, well, I just want 10 times more money. It's not because of that, right? For a developer, it's obvious, but for a non-technical person, it's not so obvious. It's the same job, it's the same software. Why does it cost 10 times more? Okay. Many times it's not very obvious for non-technical people. So this is also very important aspect to consider when you have this kind of projects. But okay, so what is software? Basically, software are the programs and other operating information used by a computer. If you look at the Oxford Dictionary, and basically a program is a detailed plan or procedure or set of steps executed in a particular processor or computing machine that is executed sequentially, unambiguously, and can be reproduced and will produce the same result. I mean, if you punch into a computer 2 + 2 and every time it gives a different result, maybe it's not a very good computer, right? You expect it to be consistent, sequential, reproducible, and things like that, right? So this is kind of a program that you expect it to behave exactly as you intend it to behave and to produce the result consistently. Okay. But again, there are many definitions. We don't need to be very religious about definitions. It's good to understand now. Software and software quality basically is very important. Everything you want to buy, you want to be quality, right? When you go to buy a T-shirt, a food, you want quality, right? No, you don't want to go and say, give me your worst thing, you know? You want quality, some basic, whatever it is. For you, you have certain level of quality depending what you see, but you want quality, right? It doesn't have to be expensive luxury. It has to be quality from your perspective. So software is the same. You want software quality. If you download an app and it crashes like on the first install, and when you try to log in, it crashes 5 more times, you'll just remove it, right? So you want quality. Quality is important. So it comes with the software, and that's kind of the QA, the quality assurance engineers. They are tasked with ensuring that the software is developed with quality, or at least released with quality. And so security is somehow related to quality because it's also a particular type of quality. Okay, in the sense that it is not just quality, but it's a quality, but it also gives some guarantees. Okay. It's not that it just not crashes, but it also will not leak your data, for example, right? It's also a quality. Because, for example, you can go to a fancy restaurant or to a restaurant, okay? And you have quality food and you give your credit card number, but then they leave your credit card number for everyone to see. So you get quality, but you don't get very secure quality, okay? So that's kind of one of the simple examples to put. So the software quality, there are again many definitions. There are also even standard type definition. You can look at this standard ISO 25010. So first, the software quality is correctness, right? As I mentioned, 2 plus 2 equal 4. 2 plus 2 equal 4. Whatever you run, no matter who runs it, the correctness should be there. Like whatever the programmer intended to do, to display 2 plus 2 equal 4, it should be there. Like correctness is a must for a software, and it's kind of a must for anything. Then, of course, there are other types of quality, performance, how fast it is, how small memory it consumes, on how many processor does it need to run, extensibility, how easy it is to extend the software so that you can develop new versions, not from the scratch, how easy it is to maintain it for the developers who maintain it. Like after 10 years, if you give it to somebody, will they need to learn like 100 books of COBOL or Prolog or Pro language? Maybe you've heard about these or not. So these are also quality of the software, maybe not directly visible to the user, but if, for example, if there's a software that is hard to maintain, then you will, as a user, you will face consequences, because if it's hard to maintain, of course, the maintainer will do a very bad job at ensuring quality because he cannot maintain it. It's kind of, there's a rusty car and you bring every day to the mechanic, and mechanic just puts this WD-40 just to get the rust, but it doesn't fix the main problem of the old or very unmaintainable car, right? So, but then security and trustworthiness is another very important type of quality of the software. And of course, there are many subcategories like resilience and safety. Can it operate for safe operations? For example, imagine you have these industrial machines which cut wood, and there's like a big saw circulating at many rotations per minute. Now, maybe you have faced with Windows or other operating systems when you run software, or it crashes, it gives you a blue screen, or the program starts dragging, right? It freezes, you cannot do anything. So imagine you're operating this and somebody is very close to that saw, and it's dangerous, and you press the red stop button and it doesn't stop, you know, because it's thinking what to do. So safety is also a very important aspect of security and trustworthiness, even though it's not related to data, like personal data, credit card number, date of birth, and so on, right? So again, it also comes with security, because if the hacker can make an impact on the quality in such a way that it's not safe to use that software or system anymore, then it's not good. Okay, so let's look at secure software kind of definition. So the software security, or the idea of secure software, is the idea of engineering software in such a way that it continues to function correctly under malicious attack, right? So if somebody tries to hack the software from different angles with different types of attacks, we don't discuss any particular attack now, but a secure software, we should be able to withstand this kind of attack, okay? So if you're building an application or a system like digital smart system with million users, and the important thing of your system is the data of the users, right? Then maybe very important type of secure software resiliency would be that that particular software doesn't leak information about the user. It can crash, it can maybe not connect to the networks from time to time, but maybe very important for that type of software is not to leak that millions of records of the users, right? If its main goal is to protect the users. So depending on the attack, the functionality under malicious attack can be different. But then, well, sometimes things in software and in security, they are hard or not hard. And again, hard and not hard is a very subjective feeling, right? For somebody, doing 50 pull-ups is easy, and for somebody is impossible. So again, hard and not hard is relative terms, and it goes also the same for software. If you give two programs or a program to different programmers, they'll say, well, this was hard to write these 10 lines of code, and the other will say, oh, I spent like 1 week Googling and I still couldn't write it. The same program, right? The same requirement. So, but what, again, software security is hard. That's why it's mentioned it's hard, okay? So what is not hard, first of all, Not hard means possible, easy, fast, cheap, there's no constraints. So basically, if you want to write not secure software, which is relatively easy, then it will be fast and cheap, and there will be no constraints on the software. You can run it anywhere, any way, it can crash or not. So basically, and many times it's even no knowledge required. You have these software languages where you just drag and drop different visual blocks, they connect and they do some magic, and the programmer doesn't know what happens inside, okay? So we also have this kind of thing. So writing software is relatively easy, and definitely writing secure software is not that, okay? Writing secure software is definitely not that. Now, when I say that writing secure software is hard, what hard means? It means that, of course, it's not impossible. There are definitely secure software or resilient software. Like if you think the software that runs on rockets that go to space and Moon and Mars, they need to be very good quality software, secure software. It withstands the attacks and all the other cosmic rays and whatever not. So right. So it's not impossible. It's possible to write, but definitely it's not easy. Okay, you need you have to be a NASA engineer to write that kind of software. For example, if you're writing secure software for rockets, it's not fast. You cannot just sit down and tomorrow you have a full program running on the rocket, okay, on a space mission. It doesn't work like that. So again, that's really important, and definitely it's not cheap. The expertise required is very expensive. You cannot say, okay, I have 5,000 euro. I want to write the software for space mission. Not possible. Who will write that software for 5K? No, people learn like all their life to write secure software, so they'll not do that for 5K. It's not an application. So again, sometimes people in this fast-paced, digitalized environment with smart solution, everything can be done, drag and drop, and click, click, click. Yes, this is true, but of course there are limitations that we need to understand to convey the right message, whether we are technical or not technical. If we say, yeah, we can do it for cheap, free, fast, okay, then you promise false promises, because it's not like that, depending what you are developing, right? So again, and usually the hard part is that you also have constraints that you have extensive knowledge required for that, for writing secure software or secure system. And most of the time, all the constraints are true at the same time with end. It's not easy, it's not fast, it's not cheap, okay, and requires extensive knowledge. So this is usually what is required to write at least basic secure software, okay? So unless you checkbox all this, very likely whatever you build will not be secure, okay? Now, short answer, or too long didn't read, why is writing secure software is hard? Well, because secure software is a very complex multi-dimensional problem, and each dimension has its own challenges. Well, you think, well, it's just software. What are the dimensions? I mean, there are operating systems, hardware, processors, interfaces, communication protocols, parsers, memory allocation. I mean, there's so many stuff that can go wrong in a system, and the attackers will attack. I mean, when you write software, you are writing a piece, but the attacker has all the time and all the access, right? They are not constrained to what you think they will be constrained to. And to give you an example, well, basically you need to trust the user when you're writing software, but you shouldn't trust the user, or you cannot trust the user. So what you see here, maybe, I'm not sure, it's quite small, but basically it's an old computer, and let's start from the beginning. So this is a USB drive, which is connected to a USB to PS2 mouse connector. Doesn't make sense, but it fits, right? I mean, and then this PS2 mouse connector is connected to a PS2 S-video connector. Again, doesn't make any sense to connect a mouse to a video converter, right? And then this video converter is further connected to some digital video interface, and then it's connected to some parallel port, which is used for printing and some other stuff. So none of this makes any sense and is not functional. right? But because interfaces fit, the user will always find the possibility to put your system in such a way that you never intended to, or never designed to, or never tested. How many of you test like these kind of scenarios? And it's possible. I mean, if you take all these interfaces and you find the old box, you just do this exercise. Just find any random box with all these converters and start putting them together. You'll find amazing Lego playground. And it works in the sense that, yeah, it doesn't achieve what you want to achieve, to read the USB on the computer, but you don't know how the system will behave. Maybe the driver will just go and crash because it, I don't know, voltage or whatever, right? So this is just one example. And then there is another example where even simplest complexities can be, can become an overkill from cybersecurity perspective. So if you have two functional devices by themselves, like a rake, which is functional by itself, and you have an X, which is functional by itself, but then if you put them together in an unexpected or not intended way, okay, the consequence is, quite brutal, can be. And this is true. I mean, this is true for any system. If you take, I don't know, some component from Stack Overflow and you put to your MySQL database, and you don't put security and you have millions of users, yeah, this will happen for sure. Okay. Yeah. So again, even like complexity, when you add two different simple things in a complex environment, the complexity is not 1 + 1 = 2. Usually it's 1 + 1 = 10. It's like exponential scale of complexity of things you have to think about, how they can be combined, how they can be used, where it can hit, and things like that, right? So this is something to think when you generally design systems, not only software, but, well, every day, today is software. Now, when I mentioned that it's a complex multi-dimensional problem, and each dimension has its own things. So, for example, the software fundamental dimension is that writing correct and secure software is generally challenging. And just to give you an example, Linux has 27 million lines of code. You can imagine how many bugs can be there and how many combinations and permutations and inputs to be tested and so on. And the Ubuntu has 50 million lines of code, and it has, well, 137,000 bug reports. So this is interesting for multiple perspectives. Here you have only double the lines of codes, but the number of bugs are significantly bigger. Why? Well, because Linux is just a Linux kernel, and is also developed by a specific type of developers who are like developing it for 20 years. And Ubuntu is more like a shell on top of a kernel, which comes with a lot of software and a lot of integrations that are basically many times like this. Okay, this is can happen. So that's why the number of bugs, and these bugs can be from very simple annoying bugs that something is not displaying correctly to really bad bugs where Ubuntu system can hang and crash, and you don't think that Ubuntu, for example, is installed only on your PCs. It runs on servers, it runs on many web stores like in the cloud, and powers many projects and so on. So it's not only a home operating system, it's very versatile. So let's look at very simple example. So there's a problem. Let's say problem number 1: write code to print the first command line argument. How many of you programmed C or had C classes? So you're more or less familiar. I mean, we are not going to do really complicated C stuff here. Is not the point. But so the solution would be something like that. I mean, I made abstraction of include std.io and all that main. So write code to print first command line argument. Like, what is the code to do that? I mean, this is the main gist of it, right? Print argv1, right? I mean, main, whatever, that is like needed boilerplate, right? The code that does that is this one, right? Just print RGB. Print, just two invocations. Okay, you can see that there are two commands. Is this code correct? Question. Does it print? Like, does it do what it's supposed, like what is asked to do, to write code to print the first command line argument? Yes? Everybody agrees? It's correct, right? Okay, so test 0 or test 1 or whatever your counter initializes with. So if you run program hello, it will print hello, right? So generally is correct. Now, if I do test number 1 and I give it hello and then I give ampersand, percentage yes, percentage p, percentage x, percentage. If you've programmed C, right, you know what this percentage yes, percentage p means. Basically, formatting string, right? So with this test, it will crash at some point, depending how it is being compiled, the operating environment, what is in the memory before that, what have you run before. But if you run it enough time on enough computers, it will crash enough number of times to show that it crashes. Okay. So it's not random in the sense that it's kind of deterministic, but in not a consistent way. So what it means that the answer is this program is generally correct. It prints the first argument, but is it secure? It is not secure, because if somebody gives an argument like that and can crash your program 50% of the time, your software is not secure, right? I mean, the hacker has all the time in the world to give so many arguments to your program that it will crash, but your system will be unusable, right? And when the system crashes, the main thing for you to understand is that the crash is very important in the sense that your system may become unavailable for millions of users. Crash means the system is not available. If I can crash your application with just a simple thing like that 1,000,000 times per second, you have no system, you have no product, you have no application. And it's obvious, no? You want to make a system which works, where people come and use it and it's available. Okay. So yeah, the program is correct, but it's not secure. Now, let's, if we put the question, write code to print the first command line argument and it doesn't crash, so of course, then the answer, yeah, this program is incorrect. Okay, this is not the correct program to write, but print RGB. Because now, if we want it to make not crash, then we have to do a lot more programming. We have to add a lot of validation, sanitization, removing stuff, making sure that, right? Or we can do something else. But definitely this program is not correct anymore for very small update to the requirement. Okay, so you see the requirement update, it doesn't crash. I mean, if you go to the CEO and say, well, we just added this line to the requirement and we require 50,000 more euro just because we added it. Like, so this is very important to understand that a couple of words can change everything, and it's not that obvious. Okay, it will just we add a couple of lines of code. Sometimes it can be just a couple of lines of code. Okay, but this is just very simplified example. If we say that okay, the requirement is to write code to print first command line argument and not crash, then possibly the one correct solution to this is to properly use print, for example. That's kind of, again, a very simplified example. But if it's done like that, then everything which comes here will be treated just as a string and will just be printed. Okay, not interpreted as a format string and so on. The fix can be simple, but it's, again, not always like this. You are lucky if all your security fixes are like that. Okay, usually it's just in the dream. Usually it's much more complex. So now, this kind of program, you see the requirement was changed a little bit and also the code changed a bit. So in this particular case, now it's correct and it's also secure, or at least not generally insecure. It will not crash anymore with this kind of parameter. Maybe it will have something else, then it will have some other insecurities, okay? But for this particular type, it's generally not insecure. Okay. So do you get the point of how a small change in the requirement or the statement and you have to pay attention to every word, what it says. If somebody says, yeah, write me a program that doesn't crash, then you have to be really, really careful what you promise or what you deliver. Because if you deliver something and then they say, look, I crashed 50% of the time, that means I don't pay you because you didn't deliver what I asked. So, yes, then there is the other fundamental dimensions or kind of antagony is the correctness and security we can achieve, but then sometimes the performance, or most of the time the performance will be impacted and the ability to debug will be impacted because we have to do a lot of things in the code, right? We have to do additional checks if the input is not malicious, if it's not trying to do malicious things to the system, and all this costs execution cycle. It costs time, operating system, memory, and so on, right? So the performance can oppose security, so performance and security can be on the opposite side of the things. You can make super secure system, but it would be so slow that it's not usable. And if it's not usable, nobody will buy it. Because if it takes 30 minutes just to boot up your phone, you will not use your phone, no? If it takes 5 minutes from the moment you press an icon until it shows, it's not instant messaging, it's 5 minutes per click messaging, right? So again, if its performance is impacted by security, is also not good, but it's the fact that you need to do a lot of stuff for a secure software. Then ability to debug in order to make it better, to improve it over time, is also important because you always want to push updates or see what's the problem with your system, or especially if you are building applications for millions of users, then you want to collect all these crashes and bug reports from millions of users and then fix them and give them updates so that they don't even feel that there was a problem, right? Because if you have a million users putting you 1 star in 5 minutes, you're not happy with your software and nobody will install it, right? So you want that they don't even feel that there is a problem, and in order to do this, you need to ability to debug and to provide updates, but in order to do this, it can compromise security. Okay. Another thing to think. Then, of course, we have, there are systems, especially in this critical sector, such as aerospace systems, that the correctness can be formally proven and verified. Okay, we can verify that the program is correct, that the program is secure, just by checking proofs for how the program is written without even running it, right? So here we can run it with enough tests, and we will see that it crashes. So we kind of verify by testing, okay? But there's other cases where we can just look at the program and we can verify by a mathematical proof. But the idea is that it works for very small examples. It's a very nice kind of toy. You can show, yeah, I can verify this program is correct. I can verify this program is secure, but it's for a couple lines programs. If you have 100 million line of code like Linux kernel, then it's impossible to verify because, for example, this is just an example. You have a summation program, like a program which goes through an array and sums all the elements. Pretty simple, I mean, to implement, and pretty simple to read the algorithm, and pretty simple to read the implementation, right? So, and it's also a very simple program. I mean, you have an array, okay, you just add all the numbers. I mean, the simplest program in the world. Maybe the second one you wrote in your life, hello world, right? But then, just to prove that this program is correct, not secure, just correct. The proof, like the formal proof, is this long. So 3 lines of code, you have 27 lines of whatever mathematical proof, but it is correct with all the formalization and all that, and ensuring that indexes and so on and so on. Now imagine 100 million lines of code to put through the same process, okay? So it's not possible, okay? Or it costs a lot of money. You need big computers, big brains, big salaries just to make sure that your 100 million line of code project. And I really hope that some of you will end up writing some of these 100 million line of code projects maybe 5, 10, 50 years from now. We don't know, because you never know. But that's the whole idea, right? If you stick yourself that you'll write only 10 lines of code for the whole your life, maybe is not too ambitious, but of course it's going to dream big, 100 million lines of code, but then you have other problems that you cannot verify security or correctness and so on. And then, yeah, then not all operating systems and programming languages that you choose can be easily formalized, even if you have the money. You have the big money, you have every smart people in the world, but you choose the wrong language or the wrong operating system. It just doesn't support your formalization or testing, okay? And you cannot do things. So again, choosing technology is also an important aspect, and you have to do it in a thoughtful manner. You have to think not only that you have a deadline tomorrow to show to the investors. You have to think in 5 years. What if I grow from 10 users in this room to 10 million users in 1 year? Will my system still be performant? Will my system still be good? Do I have to write from the scratch? Right? So, and if you choose something and when you suddenly start to grow some systems, some software, then it's really hard to change. Okay, but once you have a couple thousand paying users, it's not that okay. I just rewrite everything and change the system. Well, the system is always in use. It's like a moving train. You try to change the wheel on a moving train. Can you try that? Yeah, maybe, but will you be successful? Maybe not. So this is kind of a similar analogy. You have a big train, many wagons, big speed. Okay, and then there are also certain security bugs that are undecidable. There's what's called the halting problem. So you never know when the program stops. That's kind of the renowned halting problem. So it can keep running or can stop. You never know whether it really stops, right? So that's, well, you can read more about halting problem. It's fascinating. But then the idea is that many of the attacks, such as denial of service, is about stopping proper execution of some software or some system. So you actually don't know if the program has really stopped or is stopped by an attack. Of course, you can see that the program is kind of in a halted state and you can kill it. But maybe it's halted because the execution is intended to be halted, right? And it sleeps for whatever, right? So it's a hard, if you want to protect automatically from some attacks are inherently hard to protect because, well, halting problem. So denial of service is basically one of the tough problems to solve for many programs and operating systems because, well, we cannot decide whether it's completely blocked. And then we have well, other types of security bugs that may come to your software or to your system from the hardware level. For example, you have the rogue hammer attack. Maybe you have heard about them, and they are coming from the RAM chips. So how the attackers are using the RAM chips. And then you have to formalize the RAM chips, and this becomes really complicated. So why should you be worried about RAM chips and raw hammer attacks? Well, I'll give you a very simple example. If you have an application that processes credit card numbers, those credit card numbers go through the memory. You have to load them in order to compare them or to check up in the database. So they go into memory, okay? Once they go into memory, they are becoming target for the attacker. And because the design of the RAM chips is made in such a way, they can do some read and writes to certain locations of the RAM so that they can reveal the contents of other RAM addresses or locations. So they can use, you know, kind of they are knocking on this part of the wall and they are hearing if the wall is cardboard, right? They are knocking here and then they can listen here. Okay, oh, it's a 0. Oh, it's a 1, okay? So they can understand what's inside of the memory where they shouldn't have access, right? So, and this is really hard to protect from. Of course, the usual applications you would be writing maybe will not require direct protection from this, but in order to understand that there are so many ways the attacker can get the credit card from your application, but again, you have to understand and mitigate this kind of risks. Then there's also the integrated development environment and DevOps and continuous integration. And of course, you want to do everything in agile way, right? You have to quickly build, test your system, make some code, it again continuously test and check that you didn't break anything or your developer didn't break anything. But many of these systems, they can only detect simple security bugs. They cannot do a complete security or penetration testing, and even less systems come with formal methods that can check your programs are good or complete or correct and so on. Okay, then we also have the human supply chain problem that, okay, most of the code is written by humans and tested by humans and maintained by humans, right? So the question, who designs or writes the code? That's very important. That's, do they understand the cybersecurity? Do they understand all these factors, right? Then who checks and reviews the code? Do they have an understanding of the whole architecture, the whole vision, or the whole cybersecurity aspects? What are the possible attacks? What are the possible inputs? Then who tests the code? Okay, some people are very good at testing functionality. They can find really good functional bugs, but they are not good security testers or penetration testers, right? And that it means that they miss security things that the attackers would go after. And that doesn't mean that that particular person is a bad tester or a bad QA. They are just different types of qualification, right? So then who uses the code or who uses the application? Then you can have intentionally malicious users. For example, if you have a system where there is some financial incentive for playing games, of course people will try to find ways to get free money, right? I mean, it's part of the game to get free money. So if they know there is a financial incentive in the game for, I don't know, breaking with blue, red, whatever, I don't know. There are so many games that can give money, right? 1 cent, €1, I don't know how much. But if there's some financial incentive, there will be kids to adults who will try to find a way to get 10 euros by doing as less as possible, right? So it also depends who uses the code or the application and what is the main intent of the application. And last but not least, of course, are all qualified or certified or for each particular step in the process. This is a very complex process, and it's good to have qualified people to do this. Well, the secure software developer is definitely an existing species. There are such persons, but usually they are very expensive and rare heads, meaning that you have to pay them very well, and even if you have the money, then they are really hard to find. Okay, it's kind of a collectible. You have to find people who can write secure software, right? And also test it securely and understand the security implications, right? There are many examples where people with very good programming skills have introduced bugs into Debian and Linux kernel because they didn't understand security, okay? Cryptography and randomness and things like that. So they did code, from code perspective, they were like doing the correct thing, but from security perspective, they lacked things, and it ended up to introduce security vulnerabilities in Linux and other operating systems. So, and at the same time, it's the problem, the human dimension is that the cybersecurity and the ITNC, where the shortage is quite big, right? So if you would ask me what to learn these days, I would definitely say learn cybersecurity or some aspect of cybersecurity, because there are already 4 million of shortage of talent at European level. At global level, it's even more. Yeah. Economic dimension of the software. We are all in the business of writing software, not just because it's fun, but there are companies generating money, bring money, and so on. So there's economic component to the software, right? They are trying to make some processes more efficient, bring some money. So usually it is time to market versus software quality and security. And normally time to market usually wins, because this is how economy works in everything. Time to market is very important, and everything else, the quality and the security especially, goes last. And that's very, very sad, but it's the reality, and we have to think when you design your systems how you can put that in. Then there's the cost component. As I said, the security expertise doesn't come for free. It's a special expertise, and it's acquired by a lot of skill and learning, and is similar to any other additional expertise on top of everything, right? So it adds costs. Then competitiveness and features versus software quality. We want to add as more features as possible, and as you have seen the Rake X example, right? The more features you add, the more unexpected consequences you can have. And we usually just add them as fast as possible. Let's add some users, and then we also add some crypto, and then we also connect them to their credit cards, and then we somehow store it in plain text, and then we have big problems. Okay, so the economic dimension is definitely a calculated risk decision, but it many times lacks this security understanding. How much does a real security cost, and is also hard to quantify. It's not very simple to quantify how much does, if your application is hacked, for example, how much does it cost you? How much does it cost your users? Like, it's not very trivial to quantify all that information to make a number and say, well, if we don't put security, we will lose 5 million euros. You don't know, because it could be, think about this. If it's biometric information like fingerprints, how do you replace fingerprints to 100 million people? If your application, or if it's their faces in your system for authentication, how do you replace faces, 100 million people? How much does it cost? What are the consequences for some users? There are many other economic factors that you cannot easily like calculate or put into even perspective, think about, right? So there are many things like that to think. Yeah. So there is some good quote here from Gene Spafford, very renowned computer science scientist. I will leave it here. Most consumer development still stresses time to market rather quality. The burgeoning field of Internet of Things, now everybody is Internet of Things and stuff, is even more in this direction, because it's like consumer is based. Okay, let's get smart meter, smart TV, smart thermometer. We connect everything to our network. Then we connect to the same network with our passwords and Wi-Fi and VPN and email. And then suddenly we find examples where casinos are being hacked through a fish tank thermometer for 50 million euros, right? So like if you think fish tank thermometer, 50 euros, casino lost 50 million, right? So again, you would not expect that, but this happens in real life. Okay, this is a real example what I gave you with the casino. Yes. So I think we are coming to the end of the presentation. I hope I gave a lot of food for thought in that sense, in cybersecurity perspective. Maybe before we conclude, I would definitely like to make some exercise, maybe to take 5 minutes each project, maybe to group together, and I'll look 5 minutes. You try to think what are your cybersecurity risks in your solutions, like I don't know, user details, GDPR, credit card numbers, denial of service. I don't know your project, so try to discuss a little bit. What do you think are the most pressing cybersecurity things that you didn't think in your project? Okay, and we can go over them in after that 5 minutes. I will check each project, like ask a question, and then similar to what I'm sorry. What is your name?
Steven.
Steven. Like pretty much similar to the example Steven said about their users and database, and that they need to store it encrypted. This is just one example how we can we can discuss. So maybe the other projects can take a similar approach, thinking what are your top 3 cybersecurity potential problems. Again, the user's example is a good example, but let's also have some other examples. So of course, if everybody says that we will have 10 million users and we need to protect them, it's good, but maybe you have some other better examples as well, okay, in your applications, because I suppose they are quite diverse, so we can have some examples there. Is it clear what we want to do in this 5 minutes from now? And then in 5 minutes, we will have again a quick, I'll ask every project, and then we have very short discussion just to see if there is something you can put in your final presentations about cybersecurity risk and how you are dealing with it.
This one is classic. I think like the first with the.
Okay. Who wants to start first to detail their cybersecurity items?
We are quite sure because we don't have so much software in our solution. So maybe the only part where we could include the security software is when our customers are paying the cards. So maybe card payment.
Okay.
But that would be like collaboration with some bank. And actually, that's the only part.
Okay. What solution are you developing in a couple of words?
What kind of solution?
Yes.
It's a service for companies, business to business service.
Okay. Okay.
So it's not software, it's actually like activity.
Okay.
Provided by us as provider.
Yes. Okay. Makes sense. So basically, in your case, this payment risk is outsourced to Stripe or still PayPal or whatever is accepting your payment and stuff.
Yeah, so basically, like everything should be like an existing, very well designed technology for us. Like I can say, like our highest IT security concern is like if the bank handles the payment to us. So I guess. But other than that, of course, we need to have like some kind of database with our previous partners, for example. That might be that's like a bigger problem as well. So yeah, it's like normal.
Pretty standard, so to speak. Yeah, definitely good to always include the, well, you know, at least you don't get stupid questions afterwards. You say, well, GDPR pretty standard this, and payment is anyway outsourced risk to third part like payment processor or bank. So
But in this case, I think still it's like wise to consult with the IT security specialist and at least say to the partners that we are thinking about it also. But
yes. Yeah, that's the correct way, even for this small kind of or not huge software project, is at least to verbalize or to outline that we know about this and we are aware, we have the process, and these are the main risks, and anyway one is outsourced. So that's a good approach. Yes. Okay. Cool. Who wants to go next?
Okay, we have a fake news detector, and we think like the weaknesses of our solution is like we will have database, and our machine learning process will take information from that database. So if someone will hack to it and change some information sources and everything, our machine learning will do the crazy stuff. So it will be not like it's going to be real. So yeah, it will make a mess. And also we will have users that which they can vote, like if something is true or false. And if someone will hack it, like okay, I will be a fraud and I will just say this is true. It also can make a mess in our database. So our database is a weakness also inside, but from the outside. And also we will have a subscription, so credit cards, and GDPR, because we will have users that can register, and we will make some news, or I don't know, detected fake news for them, just personally to them.
Yeah.
So we will take some information from them, so GDPR and things like that.
Okay. Yeah, you have quite some parts in the system. So definitely the database is one thing.
Yeah.
And protecting against the bots is definitely an important part, right? Maybe considering this capture kind of solution where, you know, Google Capture, where it asks to mark birds, bridges, or whatever, so that you prove that you are human. So maybe mentioning this or implementing this or having something like that. Yeah, definitely, if you have payments, maybe usually with the payments is better to use this outsourced payment processor like Stripe or PayPal, because they handle all the sensitive stuff like credit card data, and you just get, okay, amount is paid and you pay just small commission. So
yeah,
maybe it's good to think, I don't know, maybe you want to process yourself. It's good that you think about that. And yeah, pretty standard user data, GDPR. But where you are doing the machine learning, are you using cloud to do machine learning and stuff?
We are using clouds.
The machine learning, like
The type of the machine learning?
Where you're training it, in the cloud?
I don't know, but where do we store the information from machine learning? My idea was like a physical database, because it's more secure, I think. But the cloud can be also.
Yeah. So just a point for if you are doing machine learning, you're doing a lot of data processing. So if you are doing it in the cloud, it costs money, right? So there could be, well, depends, but many times it can cost money. So there's the type of attack where people will just send data for you to process, so your bill is going, right? And you have to also consider this. This is also an attack.
And so, like, the physical database should be better for that, no? Or? No.
I mean, it's the amount of data you process. It's not the physical database. I mean, if people keep sending you data, okay, here's more, process, so that you have to train. So this is something to consider for everyone who is doing some kind of paid processing in the cloud in general, not only machine learning, but something for you to.
Okay, thank you so much.
Yes, thanks. Who wants to go next?
So our solution is a navigational app for disabled people.
Navigational app for disabled people. Okay.
So we have like the standard user information, the identification of user to prevent any double accounts and false accounts. And we also store the route information for further research to help universities and stuff. So we have seen that. I mean, it's standard for the user login information for that. It has to be secure, not to have any leaks. And again, for the route information, it is kind of personal. I mean, it's going to be anonymous. We are going to store it anonymously.
Okay.
But again, it is user information data. We don't want it to leak anywhere. Okay. Yes, definitely. That would be personal if they are going from home to home, whatever. Okay, so that's the point. Okay.
Yeah, so the security point is where like the main information about the user are going to be stored outside outside database but encrypted.
Okay.
And then from the applications, the big data are more sensible. So we want to store them anonymously for the user, but just on a form using a kind of pass by identifying them by pass, and not by the name of the user, but using as a text the pass.
Okay, so some kind of pseudo ID. Okay. Okay. Yeah, I guess everyone having users in their system definitely have similar things to consider. For your case, I think it's also the route. For example, if somebody hacks the route you generate, and then they get into like bad area or intentionally, because especially they are disabled and there is an accident and you have liability. So it's very important that also to consider that the integrity of the route or like the validity of the route is not tampered with.
Because it works with some user advices on certain tasks, we wanted to have a kind of strong identification of the users. That's why we are going to ask for the number of telephone
or some bank or some bank details. Yeah.
Yeah, or some identity card, but maybe more.
Yeah, definitely strong identification is good term because it can vary by country to country. Well, in Finland is the bank, and in our countries is the telephone number, and in our countries is different, but strong, relatively, yes. Okay, good, thanks.
Thank you.
Who wants to go next?
So we have the same user credential data thing that Patrick mentioned, but I think the thing that is different for us, we have these sensors in smart insect farms. So basically, since the sensors are recycled smartphones, they might have outdated Android security patches, and that's maybe the biggest problem. Also, we have the risk, since they are like used as cameras. We have the risk that someone intercepts data when it's being delivered to the server. And well, technically, no one should be interested in watching insects, or pictures of insects. But if there's a reflection to somewhere, these kind of types of things can make it more, critical type of data. So yeah, I think.
Yes. Okay. Yeah, I think that's definitely one valid point for the video feed. Well, the camera can be moved by mistake, and then it captures part of the face or somebody's face, or you don't know what happens to the camera. You assume it looks at the insects, but yeah. So that's definitely important thing to consider. Well, I don't see. Well, unless insect have needs to click that they are not a robot. I don't know other things you need to protect. Okay, good. Who wants to go next? Couple more projects, I guess.
So our application connects grocery stores with post-to-date products to customers who would like to buy them for cheaper prices. And one of the main concerns about our solution is that the customers and both from the grocery store side and the customer side, they're going to connect to our database, and they're going to do interactions with that. And for example, they can scan barcodes, but obviously, as you can also experience some kind of grocery store and check out the counter, the barcode scanner doesn't work. So we have to have a way to enter the barcodes manually. Now that field where you're entering that, we have to pay attention because that's going to directly interact with our database. So we have to restrict certain use of certain characters. It should only be numbers. Numbers, that's part of the solution. And also for every single transaction we make in the database, we're going to assign a user ID to that, so in case anything happens, we can further investigate such cases.
Okay. Yeah, I think that's the case right from Jyväskylä University. Definitely, you have the critical thing, but you also have to connect, or if you connect to the supermarket network, that's a big risk, right? You have to consider besides your application, and then also the possibility that somebody will put bad, like fake QR codes for your application to scan, and then they go to malicious site. So maybe thinking about that, your application may get. Well, you said that you validate that it will be barcodes, like with numbers or digits only, but in case at some point QR codes will be used for product as well, maybe also to consider that QR codes could be leading to malicious sites, and you should restrict only to certain type of QR codes.
The thing is that I think that the QR code possibility will be only for the store workers, because in like they will have to scan it to provide the test close to the product. So
they become a victim.
We would know the ID of the person who entered
it. Yeah, but then it also needs to be considered. If somebody scans the QR code in our application, there's potential for misuse because, well, you don't know what's in the QR code, you scan and then boom. The whole, yes, I think we have one more project, the last one, yes.
That's us, right?
Yeah, but you've explained, but yeah, did you find anything else?
Not really, because we're not really going to accept user inputs from like the general public. All of our information will come strictly from government websites, because we're doing an accessibility application also for the elderly and for the visually impaired. So like all the relevant information is going to be provided by the government, and the other extra like community style information is going to be provided by companies that offer services that can help the user base. So the companies will have it in their interest to provide accurate and non-malicious data. Our biggest security concern is going to be around our own databases and the data we store, the user data we collect, and how that's anonymized, and that's it.
Yeah. Okay. Yeah. I see you've already thought some of these things out before the lecture, so definitely on the right path. And yeah, the user anonymization is very important for all the user-related part if there is a potential of misuse, but of course. Oh, any more project left that we didn't cover? Sorry?
Our solution for minimizing the risk of contracting coronavirus is like a bracelet which takes all the information from the environment and sends notifications to the app, where each user has their own profile. And so what we need to do is provide the highest level of identity security by strictly following GDPR and encrypting our databases, and also probably help a lot is the biggest invention for users would be the two-factor authentication.
Okay, yeah, well, that's part of the strong authentication, but yeah, it can be even stronger. And definitely in your case, it's health data, so your security concerns are really high, and especially how the data is stored and anonymized, but at the same time useful. So I think you are in a very sensitive situation, because once there is a potential problem, even at the then it's really serious, because maybe there's even more medical information that is collected or something like that, besides the bracelet and the location and the movement and stuff. Yeah, but yeah, so you get the whole idea that, the point of this exercise was to get you in the mood of thinking what could go wrong and what you need to think first. Of course, there is never a shortage of things to think of in a project, especially which evolves. And but I think you got the idea why you need cybersecurity in general in any project you will do. I hope you understand that. And it's not just a checkbox, okay, we will encrypt the data and we will just show some cookie, because it's pretty serious. Companies have gone out of business because of that, right? So it's not just, okay, scary stories. This is true story, and you don't want to lose, if you build a business, a successful business, you don't want to lose it because of a stupid security thing that you didn't pay attention to. Well, thanks. I think that concludes today's presentation. Thanks for your attention and good collaboration and interaction. Yeah.